take it. For example, if I take one coolie, so the person is, imagine the person is carrying a load on his shoulder. So about 50 kg, for example. So from 1 kg to 50 kg, from 1 kg to 50 kg, he can carry, like what we can say, 1 kg become 2 kg, 2 kg become 3 kg, 3 to up to 50 kg. So stress increases and strain also increases. So for him, there is no problem. He never feel any kind of, what we can say, there is no kind of difficulty for him. So up to there is a 50 kg limit. Then 50 after what will happen? Slowly he will start bending. He will unable to balance it. So 50 is the maximum limit for him. That is what stress and strain directly proportional to each other. He can able to walk freely. So now once the weight will cross more than 50 kg, so for example, 51, 52, 53, 54 like that, still he able to walk. Like we can say up to 55 kg, for example, we can say. He will able to walk up to 55 kg weight. But after that, what will happen? He reaches to the maximum point. Then further, he cannot carry the load. He cannot able to walk, but still he can able to carry the weight. So in the sense of, if I increase the mass after this point, 55 kg, he cannot able to walk further. He cannot carry the load. Now 55 kg to up to 60 kg, he can carry the load, but he cannot able to walk. Clear? Now if the weight will cross more than 60 kg, this person will fall down. He will fall on the earth, ground, because more than 60 kg is the breaking point for him. So that is what you have to understand. I hope you all clear with the graph. Mr. Rudresh, brothers, understand? So that is the exact graph we are going to speak about the metals. So now real life also you can see. Compressibility also same. Suppose if there is a spring, you all can see. Suppose I applied 1 Newton force on this side also 1 Newton force compression. If I release that 1 Newton force, it will be back to the original position. If I keep on increases the force, there is a certain limit. It will be start compressing and it will not able to get back to its original position. After further, if I try to apply the force, still it will be compress more and compress more and compress more. There is a certain point. So after that, further compression won't be takes place. Like that, further expansion also won't be takes place. It will start breaking. So the same graph will apply for stress and strain graph. Will plot it. So that is the exact graph will come. So this is not a no fixed graph. Actually, it is a general graph for stress and strain. That is the reason they are putting a typical stress strain graph. Do you all understand, everybody? A typical stress strain graph, which we used to call it as. Now, here all of you observe very carefully. Starts from 0, A, B, C, and D. These points I will finish it to you. Just observe very carefully, all of you. OA, OB, OC, OD, and OE. So these are all the points observe. Now from 0 to A, all of you observe very carefully here. So this is what actually stress is directly proportional to strain. Have you remembered? Pradosh, do you understand? Stress is directly proportional to strain from OA or 0A, whatever it is you are taken. So OA, what will happen? Graph. It is a linear graph. Linear graph means what? Stress is directly proportional to what, everybody? Stress is directly proportional to, respond, strain. Do you understand it? Next. A is the point already directly proportional to gone. A is the limit of proportionality. After that, there is no directly proportional. Do you understand it? So A is the limit of proportionality. So after that, stress and strain are not directly proportional to each other. Now, up to here, if you want to find the modulus of elasticity, whatever it is, modulus of elasticity, whatever the elasticity, if you want to find it, which is equals to slope of the graph. That is what? Delta y, as it is y-axis and this is x-axis. Delta y divided by delta x. Class 10th, we have studied a resistance slope graph. Remember, Mr. Kadir, Narayan? That is the same thing. So up to a point, modulus of elasticity is equals to, that is what? Stress divided by strain, which is equals to slope of the graph. A point. What is the a point? We used to call it as, everybody? Limit of proportionality. So everyone has to remember that. Clear? Laksha, understood? Up to here, anything doubt you can ask me. Next Next, from A to B point, all of you observe, by changing the small change in the stress, strain will change very more. Drastically, it will change us. So that is the point we can say OB, but still there is a extension will be there. After that, the spring, there is no stress is directly proportional to strain, but still we can notice the extension of the spring. So up to B point, there is extension of spring. That is what we used to call it as a elastic region. So means up to B point, if you release the spring also, still it can be able to come back to its original position. So that is what you have to remember. So that is why the B point we used to call it as, you can see here written sigma y. The B point is called it as a elastic limit. So up to B point, the body can be reverse back. But up to which point it is directly proportional, everybody? Up to which point it is directly proportional? Up to A point it is directly proportional. From A to B, it is not directly proportional. It will be drastic changes. Small change in stress and large more change in the strain. From where to where? A to B. Note it. From A to B, small stress will change and more strain will change. Now, once the B point, up to B point, it will be reversed. Means if you stop applying the force, the spring will be coming back to the same position, same shape or whatever metal. Now, once the B point crossed, after that you can see B to C. This is very, very important. B to C. So that is what OC we will say. After B, the small stress, again same thing. Stress will be small, but strain will be what? Large. Large strain from B to C also. So now, here if you notice it, from B to C, no elasticity. That is very, very important. From B to C, no elasticity, but strain extremely high. Small stress, but large strain will be there. But at this point, remember, deforming force is removed, means applied force. If you remove the deforming force, understanding, removal, not returns to back. That is very important. From which point to which point, draw? It will not reverse to back. Up to B point, it will be reversed back to the original position. But from B to C, once it will cross us to the B to C, it will be like what we can say, elasticity it will lose, means reforming capacity it will no more. So that is what at the C point it will attain the permanent change. So most important, at C point what will happen, everybody? Permanent strain will happen. So stress becomes zero. Stress removed. I removed the force. Deforming force is removed, means in the sense of no stress further, but still strain is present. What is the strain? Permanent strain is present. Do you understand, brothers? Anything doubt? Clear?
Yes, sir.
Yes. Understood? Can I repeat once again? See, listen. From O to A directly proportional to each other, so that it will be reverse back. A to B also not directly proportional to each other, but still it will be reverse back. So B is the maximum elasticity point. So once, that is why we say elastic region. From O to B or 0 to B, we used to call it as a elastic region. Now, once it will causes B to C, small change in stress, large change in strain will take place. So once the body will attain the C point, it will, if you remove the deforming force, means applied force. If I remove the deforming force, means what? Stress will become zero, but still strain will be existed. That is what we used to call it as a permanent strain. I hope you all clear now. Anything doubt, you can ask me. Understood, Ara? Rudresh? Narayan? Yes? So that is what. Now further what is happening? So no reverse back. So strain removal also, permanent strain will be, sorry, stress removal also, permanent strain will be there. So that is why we'll take actually, this C point is not a fixed point. All of you note that also. This C point is taken as a random point. It is not a permanent point also. So it may be come at before itself, or it may be come at this point, or it may be come at this point, any point. It is a random point which has been taken, C point. So that is what we used to say that. Next, once it will cross the C point, from C to D, all of you observe, C to D, we will call it as a plastic region. So first beginning of this chapter, we studied plasticity. So means the permanent change will take place. That is what, at the C point, permanent change will take place. Up to D point, no elasticity, no extension of a spring or a metal, whatever it is. So it will be permanently will be there. But still it can be upheld without breaking. So that is what we used to say at a D point. Once it will reaches to the D point, maximum stress will attain. So more than that, like as I said, 55 kg, 60 kg, maximum stress will attain. That is what is the stress we used to say, breaking stress. So once the limit will cross after that, that is what D after, even after removal of deforming force, what will happen, you know, guys? If you apply the force, maximum stress will retain. From D to E, the metal will flow like a liquid. Very, very, very important. From D to E region, what will happen? Even though you remove the deforming force also, note it everybody. From D to E, even after removal of deforming force, wire flows like a liquid. So this is the most important point. Means in the sense of like we can say thinning of a wire will extremely, like it will be keep on extending. That is what we can say, flow like a liquid, we used to call it as. Means after up to E point, it will be flow like a liquid. But once it will be crossed the E point, the point E is called it as a fracture point, or we can say rupture point. Note it. Means in the sense of breaking point. So after that, it will be get fracture or it will get break, rupture itself. That is what we used to call it as a E point. So this is all about this graph, most important graph. So from this, we'll make a conclusions and then we'll finish it. So first point, you can notice it. Point number 1, ductile. Class 8 and class 10th also we studied metals and non-metals, ductile or tensile, both are same. What is the ductility? Metal shows ductility. Anybody can tell? Beaten into what? Beaten into thin wires or thin sheets? Thin wires.
Thin wires, sir.
That is what we used to call it as a ductility. So remember, ductility or tensile is very, very large in a plastic region. Note it everybody. Plastic region, it is extremely high. Which one? Ductile and tensile. What is the plastic region in this graph? Anybody can tell? What is the plastic region? What is the plastic region? B2. BD is called it as a plastic region. Note it everybody. If you forgot it also, please remember. BD is called it as a plastic region. And D is called it as a what? D is called it as a what? Maximum stress or breaking stress, we used to call it as. Okay. So beaten into thin wire. So ductility or tensile strength, in which region it is maximum? BD region, plastic region, we used to call it as. Next, second one, brittle in nature. What do you mean by brittle? You might be studied metals and non-metals. Non-metals are brittle in nature, means can break easily. Am I right? Yes or no? Everybody can break easily, brittle in nature. So brittle is more in, actually in brittle nature is very, very less in plastic region. Plastic region, brittle nature is extremely small. That is what you have to remember. So these are the two conclusions you have to make it. And the last one, third one. First page we have studied elastomers. If you notice it, if it is a metal, up to certain limit, it will be reversed back to the same shape. After certain limit, permanent change will attain. After certain applying force, it will be flow like a metal, flow like a liquid. After certain point, E point, after E point, it will be fracture point. But there is a substances, there is no permanent change at all. There is no kind of permanent change and yield point and all. Note it everybody, yield point. yield point a permanent change kadayadu. Directly, it will be like whatever you extend, it will extend. At certain point, completely it will break. Can you tell me what is that example? There is no yield point. So after attaining that point, it will be breaks. What is that, anybody? Yes, please. So yield point means this D point only, we used to say. Once that yield point, there is no yield point at all. There is no permanent change. Only directly it will break. What is that? Anybody can tell? Like a rubber band, you take it. So rubber band is not like a metal. What will happen? You can extend a little bit, it will release, come back. Extend, 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 extend. After certain limit, what will happen? No permanent change. Whatever the length you stretch it, if you release it, it will come back to the original shape. But if you keep on stretching, after that, no permanent region. Directly it will go what? It will breaks. Am I right? Please respond, everybody. Breaking point will attain after extending of certain limit. That is what is the substances we used to call it as a elastomers. Note it, everybody. Like a rubber band. Elastomers means no plastic region, means no BD region will be present. No BD region is present. Stress strain directly proportional. After that, directly it will attain elastic. Only it has elastic region. Only have elastic region. Elastic region. So example, you can take it as a rubber. So this is what is about this concept. So please all of you note it and learn it. Very, very important. So you all can limit yield point. Also, we can call it as a what? Elastic limit. What is the elastic limit point we studied? Which is called it as elastic limit? Which point is called as elastic limit in the graph? B point. Understand, Amma? So that is why elastic limit is also we can call it as a yield point. Means after that, it will never be reversed back. And then from B to C, stress is directly, it is random change in the strain, but stress will changes a little bit. So once it will attain the C point, the C point is anything. But from B to C, what will happen, everybody? That is very, very important. From O to C, you can notice it. What they are mentioning here? Check it, everybody. What will happen now? Permanent set will take place. Means permanent change will take place from B to C. So that C point may come any point. After that, no increasing of length, but still it can uphold maximum limit. That is what is the proportional limit we can obtain up to D point. After that, it will pour like a liquid. After reaching the E point, it will be fracture point. That's all about it. So this is what is about this graph. Then tomorrow's class, we will solve one IIT 2015. They asked the JEE advanced based upon this graph. And then we'll discuss the mechanical properties of solids. That is what energy stored in a stretched wire. So what is the energy stored in a stretched wire? 9th class you might be studied. Energy stored in a stretched wire, or we will say compressed wire, whatever it is. Two types of potential energy. In that, due to shape and size, we used to call one energy. What is that? Call it as gravitational potential energy, kinetic elastic potential energy. Everybody, can you hear me? Elastic potential energy or gravitational elastic potential energy. That is what we'll see in tomorrow's class. So we'll derive the formula and we'll solve the numericals. Okay. So this I'll stop and continue. Here till here anything doubt you can ask me, or else you can leave from the meeting. Thank you, everybody. Good night. We will meet tomorrow.